physical devices used to construct the memories, because we have talked about memories. Physical devices used to construct the memory. So memories are made up of, can be constructed using semiconductors, one thing, magnetic, okay, another is optical, that polycarbonate, okay, 3 types, okay, usually as we know that. So physical devices used to, first we'll study about the semiconductors construction. Okay, first we'll study about the flip-flop type of memory. Flip-flop. Okay, this technology used in SRAMs, static RAM, static random access memory. Okay, flip-flop. Okay, we'll study semiconductors. We'll see the understand what is this. Take this is one resistor is there, one transistor. Okay. You know the basics. This is supply, some V volts is applied here. Okay, this is output. This is input. Okay, this is resistor. Okay, this is very easy, you can easily understand. This is ground. Okay. For example, if you apply some voltage here, some V volts input. So V volts, input is V volts. Input. What will happen to outputs? When you apply the voltage here, it will close the transistor circuit. That means transistor will act as a short. Okay, roughly for assumptions, if you apply, this switch will close and it will act as a short. That means V output will come to the ground voltage. That means if you apply V volts to the input, the output voltage will be 0 volts. That means if you apply 1 here, we are reading output 0. V means 1, assume. Okay, similarly, same circuit. Plus V volts here. This is the output as usual. This is ground. Okay, this is the resistor. What will happens now? If you apply input 0 volts. So this switch 0 volts means it doesn't close the switch is open. That means this acts as an open circuit. Here it is the open circuit. That means it is an open circuit. It will become open circuit. What will happen? This voltage V volts will appear here at output. So output voltage will be V volts. That means when the input is 0, output is V volts. That means 0 means 1. It is nothing like it acts as an inverter. Okay. So this is the one of the funda. So how will you make this as a flip-flop? Okay. Flip-flop is nothing but we will connect this as back to back. I am connecting these transistors back to back. Okay. Transistor. This is output 0, ground voltage. Okay. This is input. This is another transistor. Okay, same voltage, V volts, the common voltage. Okay, plus V volts here. Entire bus. This is resistor, this is resistor. Here will crisscross connection. That means output of this one is connected to the input here. Okay, here also same. Okay, this is 0 volts. For example, take this as an output. Here we are taking output. Okay, we'll see this operation. So here also we are giving the input is coming here. So how the flip-flop will work? This is G1, this is, so this is T1, this is T2. Okay, this is gate 1, this is gate 2. Assume. How will this function usually? For example, we'll see that. I'll explain the operation, you see this. Okay, you forget about this one. Okay, for example, assume that this is, for example, input is 0 volts. Okay, 0 volts. So that means 0 volt is coming here. 0 volts is nothing, means what does it mean? This transistor is an open circuit. 0 volts. If you apply input 0 volts, what does it mean? This is 0 volts here. That means this transistor won't close, because 0 volts means it doesn't close. It has an open circuit, acts as an open circuit. So when it acts as an open circuit, what will happen? This is completely open circuit. So this entire voltage V volts will come here. So here it will become V volts. Okay, you studied earlier. So this V volts will appear here, input of the gate. Okay, this gate. That means V volts will appear. What does this V volts will make? This voltage will make. This voltage will make this transistor close and act as a short. This is open. Okay. What does that mean? Short means this output voltage will automatically becomes short, means this acts as short, means this voltage will become 0 volts. Okay. That means you are giving the input, you are writing 0 volts to the output. Okay. So even if you remove this, there is no voltage, you remove this input voltage for short duration only given. What will happen? This is 0 volts. Okay, this is V volts is written, you remove this. What will happen? Again this 0 volts is connected to here. Okay, again it is coming to 0 volts only. That means it is again open only. Again this is V volts, this is short. So this flip-flop will retain the value of this 0 even that input is removed. Okay, that is, this is flip-flop is contained, and we can read it by using read signal and write signal. You understand this? This is just cross connection. For example, if you want to write it to 1 here, okay, you will give the input for a short duration. Input here, you will give 1 V volts. Okay, what will happen? Here you study here. You just sequentially study. This voltage will come here. Okay, V volts. What will happen when the voltage comes? This switch closes. Okay. You are giving the power, switch is closing. So this transistor switch closes. That means closing means short. This acts as a short. Okay. What does mean? Short means this voltage becomes 0, because short means it is directly connected to 0 volts. So this is becomes 0 volts. Okay. Once this 0 volts means, what will happen next? This 0 volts is connected to the gate of this one. Okay. Then this voltage becomes 0 volts. So what does it mean? If the voltage is 0 means this is open circuit. Once this is open means what will happen? Whatever the voltage here will appear here. So this way it becomes V volts. So this is the way of writing. This is called SRAM, static RAM. Okay. Now we will study one more type of memory. Okay, you understand this, how we are writing, reading and writing. So we can read this from the read signal and write signal. There is some extra circuit will be there. Okay, this is the flip-flop type of SRAM. Okay, now we will study the DRAM also. DRAM is a simple circuit. For example, DRAM is simply contains a capacitor. Okay. This is 0 volts, 1 transistor here. This is write. This is for read. Okay. Here is the input, here is the output. Okay, say this here. So this is just capacitor. Okay, what will happen if you want write? For example, you want to write 1, that means plus V volts. So you apply the right signal. Right signal means if you apply the right signal means if you apply the voltage here, this transistor will close, short. That means this voltage will come and charge this transistor. That means capacitor is charged to V volts. Okay, you are giving the input, input is coming here. That means whatever you are giving here, it is coming here. Okay, this is called rewriting. You are writing 1 to capacitor. Okay, what will happen next? This capacitor will retain voltage 1. Okay, now what will happen? You want to read, you will apply read signal. That means what will happen? This will act as a short. That means whatever voltage here will appear at the output. So V volts will come at the output. So this is the way of reading. Similarly for 0 also. You want to write 0, I already told you. You apply 0 here, you close. You apply right signal, this will act as a short, so this whatever voltage will be discharged to the output, then this capacitor is uncharged. It will become 0 volts. You want to read 0 volts? If you apply read signal, it will act as a short. Just like these are switches actually, that's it. So whatever voltage you apply here, the capacitor will retain it, okay? The capacitor will catch it. It will give it to the output also when you are giving the read signal, okay? This is the way, this is called dynamic, DRAM. Dynamic RAM. So static means in flip-flops it won't last actually. Dynamic means if there is a capacitor will keep on leaking actually. So we have to continuously refresh the capacitor. And that means we have to continuously write again and again. Okay. So this is called dynamic because even though once we have written, it can't hold indefinitely. But in static RAM, see that by crisscross mechanism of the transistors, it can hold indefinitely even the input is removed. Okay. Here capacitor keeps on leaking. So we have to refresh. So this is called dynamic RAM. Okay. This is dynamic RAM. So now we'll study a little bit about differences between static RAM and dynamic RAM. Okay. So dynamic RAM, DRAM, static RAM, SRAM. Okay. So DRAM is slower, SRAM is faster. Next, DRAM is capacity is more. That means capacity more means more bits per area is more for unit area. That means in DRAM just only capacitor, 2 transistors are there for read write. That is the small. So this is small. For the memory cell it required area is small. But SRAM it requires flip-flops and read. We haven't seen that read write control signal. So SRAM requires roughly 6 transistors. It requires just 2 transistors. Okay. So density will be less. That means it requires more area. It is cheaper. It is costly. Okay. Density is more, capacity is less, cheaper and faster, and DRAM. It has to DRAM in capacitor has to continuously refresh. We have to continuously capacitor refreshing has to be done. Refreshing means you have to keep on writing so that capacitor won't leak. Otherwise, it will leak, data will go away. No need to refresh. Okay, so due to this due to this cheaper and inexpensive, and also more capacity means that means more bits per unit area. DRAMs are also used. SRAMs are also nowadays used. SRAMs are usually used in cache and everything. DRAMs are used in main memory. Okay, RAM, main memory. It is used in main memory. This is used in cache and processor memories. This is used in RAM or main memory. Okay, and one more thing is that it is destructive. One more thing is that it is destructive. Destructive means, what does it mean? This is non-destructive. What does it mean? Non-destructive means after read operation, see capacitor is there. If you read the data by transistor is there, no? Okay. See some V volts is there. Okay. If you apply read signal, okay, what will happen? This transistor will act as a short. So after read operation, what will happen? It will V volts will come here, and what will happen? This capacitor will discharge. Okay. That means read operation is capacitor will discharge and this voltage will collapse. So what will happen? Read operation means destructive. That means after reading, the data will be lost here. So here, but static memory is non-destructive. Even if you read many times, the data won't be lost. Here destructive type memory, this is non-destructive type memory. Okay. These are the difference actually. So you have to understand actually static memory and you have to write the diagrams also actually. Diagrams also I have explained physical construct, and these are the differences.